Welcome to another edition of Marjoram and Marshall Academy. If this is your first time joining us, please make sure your cell phones are off, you remain quiet during the entire viewing, pay attention, and do the examples with us. Thank you, and enjoy the show. Today we're going to be comparing fractions. Now we're going to be looking at the size of these fractions and which one's bigger. If I told you to compare 3/8 and 5/8, most of you could tell me which is bigger because with 3/8 what we're looking at here is there's 8 pieces and we have 3 of them. With 5/8 we're saying there's 8 pieces and we have 5 of them. Most of us would know that 5 pieces out of 8 is better than 3 pieces out of 8. So our bigger fraction would be 5/8. If we look at the second example, we have 4/16 and 3/16. Kind of the same deal here. This time we have 16 pieces. And what we're saying is right here we have 4 out of the 16 pieces, and right here we have 3 out of the 16 pieces. Most of us would know that having 4 pieces that are the same size is better than having the 3 pieces out of 16. So 4/16 would be our bigger number. If we look down here at the bottom, it might get a little bit trickier. We have 5/9 and we have 16 out of 32. We're going to take a look here in a minute about how we might be able to figure this out, which one's bigger. There's actually a really simple way. Now, one way we could do this is we could compare both of the fractions to 1/2. So if we look at 5/9 and we try to figure out how that compares to 1/2, the way we could do that is say, well, what's half of 9? Well, if we actually found out what half of 9 is, 9 divided by 2, that would make half of 9. That actually equals 4.5. So if we wanted to use the denominator 9/9, we would, in order for it to be equal to 1/2, it would have to be 4.5 over 9. So this is actually bigger than 1/2, so we're going to say 5/9 is greater than 1/2. If we look down here, we got to look at the denominator 32. Well, what's half of 32? If we take 32 divided by 2, we actually get 16. So if we wanted to use 30 seconds, we would say 16 out of 32. Well, that's actually what we have. So 16 out of 32 is actually equal to 1/2. Since this one is equal to 1/2, this one is greater than 1/2. We can therefore say that the 5/9 must be greater than 16 out of 32. Since 16 out of 32 is basically exactly 1/2. So since 5/9 is greater than 1/2, 16 out of 32 is equal to 1/2, 5/9 must be greater than 16 out of 32. Alright, now something important to remember is that comparing to 1/2 only works if if one fraction is greater than 1/2 and one fraction is less than 1/2. So if both of them are greater than 1/2 or both are less than 1/2, then comparing to 1/2 won't work because obviously both will be less or both will be greater. So here's an example here where both fractions are greater than 1/2. So let's pretend that I have 2 pizzas, and since you're a 7th grader, you obviously want the most pizza, and I get to keep whatever you don't want. So you want to get more pizza than me. You don't want to let me confuse you here. I say, well, I can give you 3/4 of this pizza, or I can give you 2/3 of this pizza. And as you can see, the black lines actually break this pizza into fourths, and they break the pizza on the right into thirds. So if I asked you, would you rather have 3/4 of a pizza or 2/3 of a pizza? A way you might be able to do this is actually just by visualizing it. So let's think about how big the pieces are. If we look at fourths here. Fourths are actually smaller than thirds, because if we break the same pizza into thirds, the thirds will be larger pieces. So a way you might think about it is, since on 3/4 we're going to have, let me change colors here for you. On 3/4 we'll have 3 of these shaded in, right? So if we have 3 of these shaded in, that only leaves 1 out. So there's only 1 piece missing from this pizza that you won't get to eat. If we look over here, if we have 2/3, we're going to fill in 2 of these. Same way, there will be 1 piece that you guys will not get in this one as well. But if we look at this, the thirds are actually bigger, so the section that you will not get is actually larger in the thirds, and the section you won't get here in the fourths is actually smaller. So you're actually getting more pizza if you take 3/4 of a pizza than if you take 2/3 of a pizza. Alright, now we're going to learn a way that'll work no matter what when we're comparing two fractions. And this is a way that can get confusing, so make sure you're paying attention here. We're going to find the least common denominators. Remember, when we're talking denominators, that's the number that's on the bottom of a fraction. To find the least common denominator, we must first remember what least common multiple is, because to find the least common denominator, we have to find the least common multiple of the two denominators. So let's do a quick review on least common multiple. It says find the least common multiple of 4 and 5. Well, if we think about 4 and 5 here, let's write out some multiples. Multiples are just taking the number and multiplying them one after another. So 4 times 1 is obviously 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4, 16. 4 times 5 is 20. Now let's find some multiples of 5. Got 5, 10, 15, 20. Now remember, we're finding the one they have in common. So the first one they have in common, it looks like, is actually 20. They both have 20 in common, so that is 4 and 5's least common multiple. Now we'll need to learn how to do. We're going to need to remember how to do that when we're finding the least common denominator. Let's do an example here. Okay, now I want to find the bigger fraction between 3/4 and 4/6. So I want to see which one's greater here. To do that, let's go ahead and change them so they have the least common denominator. So we got to find what these numbers will have in common. We got to find their least common multiple. So let's count a few. With the 4's, we got 4, 8, 12, 16. Now let's count a few with the 6's. We got 6, 12. Well, I can actually stop right there because we can see that both of these have a 12 in common. So my least common denominator is actually 12. Now, we have to remember one important thing. When we do least common denominator, whatever we do to the bottom, we have to do to the top of the fraction. So we know that there's going to be a 12 for the denominator on both of these fractions, but what we need to figure out is how many times did I have to multiply 4 to get to 12? Think about that. Well, I multiplied 4 by 3 to get to 12, so that means I have to also multiply by 3 on the top. When I do that, 3 times 3 is 9. Well, how many times do I have to multiply 6 to get to 12? That was actually times 2, and I have to do the same thing on the top, so times 2 on the top. That gives me 8 on the top, and of course 12 still on the bottom. So now instead of comparing 3/4 and 4/6, we're actually comparing 9/12 and 8/12, and we can easily see that 9 pieces out of 12 is bigger than 8 pieces out of 12, and since 9/12 was equal to 3/4, we can say that 3/4 is the bigger fraction here. Okay, now sometimes they'll ask you to order more than one fraction from least to greatest. So if we have 4 fractions here, they might say order these fractions from least to greatest. Now to do that, we need to find our least common denominator, but this time it has to be a common denominator between 4 fractions, since we have 4 fractions. So instead of just finding a common denominator between 2, it has to be a denominator that works for all 4. Now, rather than sit here and write out all my multiples like 2, 4, 6, 8, on and on and on and on, an easy strategy might be to first look at your biggest denominator. So my biggest denominator here is actually 24. And what I would do first is I'd say, well, do my other numbers happen to go into 24? Then you could just stop right there. Does 2 go into 24? Yes. Does 4 go into 24? Yes. Does 3 go into 24? Yes. So actually, my common denominator here is actually 24. So now what I want to do here is I want to change 1/2 to 24ths. I want to change 3/4 into 24ths. I want to change 2/3 into 24ths. I want to change 17. Well, do I have to change the last one actually? This is already in 24ths, right? So I can actually just keep this one the same. You go ahead on your own real quick and see if you can figure out what each of these first 3 is in 24ths, and then go ahead and try to order these fractions as they are at the top. Okay, now that we've done that, let's go ahead and look at how we did that here. So 1/2 in 24ths, well, 12, to get to 24, we have to take 2 times 12. So times 12 on top, we have 12 over 24. And then if we look here, to get to 24 from 4, we have to multiply by 6. So if we multiply our 3 by 6, we have 18 on top. For 2/3, to get to 24 from 3, we have to multiply by 8. So if we multiply by 8 on top, we get 16 over 24. And then we have our last one, 17 out of 24. So if we ordered those, we get 12 out of 24. And we won't write the denominators, we'll just kind of write this like this for now. 12 out of 24 would be my smallest one, then 16 out of 24, and 17 out of 24, then 18 out of 24. So if I look back at my original fractions, I know that 12 out of 24 was 1/2, so 1/2 was my smallest. I know 16 out of 24 was 2/3. So 2/3 comes next if we're ordering from least to greatest. 17 out of 24, well, that was just 17 out of 24. And then my biggest one is actually 18 out of 24, which we first had as 3/4. Alright, we're in the home stretch. We're down to our final example here. We're going to have you do this one on your own. So it says arrange the fractions from least to greatest. The fractions it gives you are listed below right there. Arrange these from least to greatest. Go. Alright, raise your hand if you got what's on the screen right now. Should be 2/6, 4/9, 9/18, and then 3/4. Unfortunately, that's all the time we have for today. If you didn't understand what was going on, don't feel bad. It's a proven fact that 3 out of 2 people have trouble with fractions. Make sure you ask questions and let us know if you have any problems.